Dr. Lee, I'm Larry Kronik. I'm the International Sales Manager for Adaptive, responsible for the whole world, but today I'm responsible for Korea. So thank you very much for the time today. Let me introduce our Chief of Software Development, Borko, based out of Europe. And he's going to do a short demonstration for you about prostate plan. A little bit about Adaptive. We've been around for quite some time now. We started out developing the last mile of treatment, which was bolus and brachy, and developed 3D printing capabilities and being able to automate the 3D printing capabilities for those things. But we saw that there was significant issues relative to planning for both skin as well as for prostate. So we first came out with Dermaplan, which we can save for another day. And then we have now introduced Prostate Plan. And in another couple of months, Borko will finish up Breast Plan, and we'll have Breast Plan as well. So today we'll focus on Prostate Plan. Borko, please take it away.
Yes, thank you.
We will be very quick. We will be very quick. And we will provide you with a copy of the slides as well, Doctor. That's exactly what we will talk about.
Yes. So let's jump right into it. Okay, so let's talk about Prostate Plan. We'll trying to take care of a couple of problems that are happening in general, not just in U.S. healthcare but worldwide. It's basically the worker shortage, the cancer care cases are up 50% by 2050. The system strain, the productivity flat, the demand rising. 90%, more than 90% of radiation oncologists report staff shortages, and it's a potentially huge problem today and in the future. This is just a quick kind of recap what is estimated by the year 2035, the shortage of medical dosimetrists. But that's not the only problem. Looking at the problems number 2 and number 3, it's just the time and variability in prostate RT planning. In general, prostate RT planning takes around 2 hours, while depending on the number of targets you're treating, the technique you're treating, the firepower of your Eclipse treatment planning system, and so on. So it's like anywhere between 1 and 3 hours, let's just say, and extra time added for Halcyon unit if you have one. Last but not least, we have an interplanar or interinstitution variability in prostate TPS planning. So not all dosimetrists plan the same, and the quality of plan can vary in that sense. The solution that we offer is called Prostate Plan RT. And hopefully it resolves all these 3 problems that I spoke about. So what is Prostate RT Plan? It's an eSAPI script for automated prostate planning in Varian Eclipse treatment planning system, and it's built for dosimetrists, planners, and medical physicists. The automated plan is generated within minutes. There is an auto creation of auxiliary planning structures like PTVs, PRVs, optimization structures. There is automated IMRT and VMAT beam placement with configurable collimator and angles and jaw tracking. We also offer template-driven inverse optimization and normal tissue optimization, integrated dose calculation, and the hotspot cooling option. Indication for use is just prostate plus minus seminal vesicles plus minus pelvic nodes or simultaneous integrated boost, and you already know these anatomical sites, so I'll just quickly skip this one. The step-by-step process happens in, let's say, 4 steps. The step number 1 is structure creation. So as I said, all structure creation is automated, especially the structures that you need for planning and tuning structures. Beam placement is automated. Plan optimization is automated. Dose calculation and hotspot is automated as well. This is just let's say a graphic workflow that you can see here and that I explained a minute ago. And the point is that you can save time with automated planning with respect to the manual planning you're probably doing at the moment. About compatibility, our plugin works with Eclipse version 16.1 and up. You need a scripting API license from Eclipse, and you need a license from Adaptive for ProcessPlan RT. It's compatible with all Varian machines, Halcyon, TrueBeam, CleanX, and so on. As I said, it's a subscription-based license, and it's based on the term length. And yeah, we already mentioned the prerequisites for installation of Prostate RT Plan. In general, application is called from Eclipse tools menu. It requires a CT image set and RT structure set file with targets, GTV or CTV, and that's all. These are all requirements basically. And plan generation is completed within a single button menu. Going through all the 4 steps of the workflow, this is the list of all the structures we can automatically create. And those are PTVs, PRVs, overlapping or non-overlapping, rectal tuning, separation of nested targets, adding seminal vesicles to PTV high, and last but not least, choosing your prefixes for all these types of structures. There is a strategic beam placement depending on how what you want to choose, IMRT or VMAT. So these 2 options we're covering. And again, in IMRT and or VMAT, you can choose all the detailed settings that you already have in Eclipse. So all this functionality is already built in Eclipse. You're just automating the whole process. The plan optimization is also automated, and the forward dose calculation is also automated. I will not go into too much detail in the user interface of the actual ProcessPlan RT plugin. We'll just quickly go through it, and then I will show you a demo in Eclipse. So, and we'll go through it again. Dr. Lee, you have a question?
No, he just said okay. Keep going.
Oh, good. Okay. Okay. Sounds good. So this is just the user interface. All good. All good. Sounds good. Sounds good. So so this is the user interface and how it looks in Eclipse. This is a prescription tab where you can put your prescription and you can put your optimization objectives. You can add new optimization objective, save, edit, delete, import from Eclipse. So you can do it all. The point is to do that once, to save it, and just call it every next time you go into Eclipse. Then the second tab is the structures tab, where you choose your structure set and you choose your volumes, target volumes, PTV high, PTV low, seminal vesicles, if you have those. So we can treat up to 3 different targets at the same time, 1, 2, or 3. Here you can choose your organs at risk. Usually those are rectum, bladder, bowel, femoral heads, and whatever you want. In the third tab, those are volumes. Here we actually generate all these planning structures. We can generate PTV from GTV or CTV, just adding a margin. We can generate patient risk volumes over, like generating a margin over organs at risk, right? We can add seminal vesicles to PTV high we can create overlapping or non-overlapping PRVs with a user-defined gap. We can separate nested targets with a user-defined gap. We can also add rectal tuning structure with the user-defined extension. And all these structures have their own prefixes, and you can navigate them in this last row of the volumes tab. Next is the planning tab. In general, you can choose your beam profile. Everything you choose is already commissioned in Eclipse, so you cannot go wrong there. And of course, you can choose IMRT and VMAT options, like with all the detailed settings that you already have in Eclipse. Yeah, this is just your choosing a unit from commissioned units. You can also add the normal tissue objective. You can do it automatically or manually, so the same as in Eclipse. And there is additional and very important feature, which is called Hotspot Cooler. So Hotspot Cooler can define and can navigate and can control your hotspots within your plan. So if the first iteration of the plan has hotspots that are higher than your definition of the hotspots or user-defined hotspots, then the algorithm goes into the second iteration of the plan, defines the hotspot, and tries to cool down that hotspot to the level that you gave to the system. This is how it works, basically. So you need to give it a percentage dose and a certain priority. And again, we will leave these slides for you to investigate later in a little bit detail. And you can ask us questions, of course, after we finish the presentation. But as I said, we can treat up to 3 targets, so we can cool up to 3 hotspots within these 3 targets. And that's how it works. Last but not least, we have a review tab where you can see like all the choices you have made during the this let's say user experience, and then you can generate the plan with a single button, and then the plan is generated. Now I can quickly go to Eclipse. So this is just a patient. I will just treat 1 target now, just for the sake of speed. And I will, from the tools menu, I will call the prostate plan. And now you will see the user interface that I showed you a while ago. So I will add, let's say, 7,000. So these are centigrades in 28 fractions. I will choose my PTV high template. So I already made this before, and I saved it. So this is just a objective template for 1 target for the prostate target, and then I'll go to structures. I will choose my RT structure set. I will choose my PTV high, which is PTV 7,000 centigrades. I will choose my rectum, choose the bladder, choose bowel, choose femoral heads left, femoral heads right. Just to add, organs at risk. Here, you will have a drop-down menu of every organ at risk that's already in the objectives list. So whatever is in the objectives list, it will show up here. If you have additional organs at risk, they will show up here. So you have to connect the type of the organ with the actual organ from your structure set. As we go to volumes, here you can generate your PTV. So the margin here is 0 because I already have a PTV, so I don't have to generate it once again. So that's why the margin is 0 for the PTV, because I already have it. But I have some margins for rectum, bladder, bowel, and femoral heads. I don't have seminal vesicles, so I won't add them. I will create non-overlapping PRVs with a 5 millimeter gap. I don't need to separate the nested targets in this plan, and I will get the rectal tuning with 15 millimeters extension posteriorly. I will keep these structure prefixes and go to the planning tab. This is the beam that I will use. I will just maybe go with the 9 field DiMRT here. Optimize collimator angles. That means that one angle is 30 degrees, and then the other is 360 minus 30, then 30, and they go kind of sequentially like that. I can use a manual NTO and the hotspot cooler. Yeah, let's see what's going on without the hotspot cooler first. Review tab, and then I can generate a plan now. So here you can see an activity log, what is going on about the algorithm itself and automation. You can see the optimization algorithm, which you can choose, of course. And again, the optimization algorithm is the one you already have in your Eclipse. Dose volume algorithm, again, is the same you have in Eclipse. If you have more than one, you can choose the exact one you want. And then we are calculating the dose. Usually, IMRT plans can be done in a minute or two. VMAT plans take approximately twice as longer because of the computing. But more or less that's it. If you have a very complex plan with 3 different targets, and then with the hotspot cooling, it can take like 10-ish minutes, around 10 minutes, or maybe a little bit more. But those plans usually take like 2 hours to accomplish. And here you see that we're already done. We already have a plan. We click, grab. I will show the dose wash. I will show 95.
How much time did that take, Marco?
A minute and maybe 10 seconds. Yeah. Just showing quickly the plan. Go to those. So this is, we want to show the PTV 70. So we choose, where is it? Okay, PTV 70. So we can see that the max dose is 102. In PTV 102.5, minimum dose 94.4, mean dose 100.4. If you want to normalize, we can normalize 95 to, let's say, whatever, 100%. So your minimum now is 95. Hotspot 103. Sounds good. Basically, this is just a single target plan for PTV 70 grade or 7,000 centigrades in 28 fractions. This is 9 field IMRT that we just did. And yeah, basically that's it. Let me go back to our presentation. Maybe a couple more slides. We had some beta testing. Basically, the vast majority of beta testers needed only 1 try to finish the plan. However, if your plan is decent enough, but after 1 iteration, but that is not your final plan, then you can reiterate, you can go into the second iteration, you can go into your objectives list in Eclipse, do a little bit tweaking, optimize it again, and then get a second plan within a couple of minutes more. Basically, all the beta testing collaborators spared their organs at risk. They covered their target. They basically needed 1 one try, these times are reported like start to end, not just the automation, but like start to end of the plan. So it's 8 minutes, like start to end in terms of like also checking the DVH and everything. So it's pretty fast in that sense. As you see, it was not only one target, we have two targets, and we had more than two targets. Larry talked about regulatory. So here is just a simple explanation of why we did not see the evidence for this, because every functionality that was shown is in Eclipse already. We just automated the whole process, start to finish, and we can share more documentation if needed. So basically, what we have with Process Plan RT is up to 85% reduction in planning time versus manual workflow. You can get a complex 3-target plan within, let's say, 9-10 minutes or so. And according to our beta testing collaborators, they could cover all their targets and meet all their organ at risk constraints. So to summarize, the problem we're facing nowadays and in future is staff shortages, rising cancer rates, and time and variability in prostate planning. We offer a solution for those problems, and that's Prostate RT Plan, our automation for prostate planning in Eclipse. And we hope to cut time of prostate planning from hours to minutes. And basically, that's our prostate plan. Now, are there any questions?
So we will also democratize treatment planning, right? So
That's true.
The person that's got 10 years of experience planning and the person that's got 2 years of planning experience are going to get very similar plans. So you'll be able to manage your staff that much better and easier to train your people as well to do complex plans, right? Without having to say, oh, let him do it because he's better at the more complex plans than that person, right? So we really kind of democratize prostate planning, for lack of a better way of putting it. Please.
Mm-hmm. Yeah. Mm-hmm. 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 Yeah. Yeah. Yes. Yeah, so it is end to end. It is end to end process, but For example, let me share my screen and maybe we can go from there. So I'll share my screen again. I'll share my screen again. Okay. So this is end-to-end process, and we got the final plan. But if you think this is maybe not the final plan, and so you can go into those optimization, and you can do a second iteration and tweak it a little bit in the optimizer window. And I think you explained that just a second ago, right? The optimization. So here you can see like all the objectives that were actually given to the plan according to the objectives list we showed. And yeah, this is you can tweak it a little bit, go into the second optimization from here. Mm-hmm. 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 Yes. Yes, makes sense. It's all automated within our script. But then again, if you want to make another one, you can do it here definitely. Yes, I believe it is. Mm-hmm. Uh-huh. Mm-hmm. Okay. Any other questions from the team? Okay. Mm-hmm. 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 Yes. 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 So yeah. Yeah. So what you can do, and we can do it here. So let's just go. Let me take the original structure set. Let me take the original structure set. And then okay, so this is the original structure set. I can just duplicate it to say work test was 24. Okay. Okay, just make another one, clean one, without the auxiliary structures. So we just are cleaning our data set, our structure set. And now we have a clean one. And now we do the automation again with the rival plan. We can, for example, we may want to choose VMAT now. We're just saving the okay. Okay, prostate plan. we go from scratch. Okay. Again, we are making the same plan with the, let's say, same template, but in the end, we'll choose, for example, VMAT or something else. I mean, IMRT or VMAT, right? But we can choose VMAT just to make a comparison. Okay, we're just connecting
Borko, I can save these templates, right? So that I can pick them, right?
Yeah.
So I can automate
course,
even the automation in that way.
Yes, exactly. It's more or less the same planning. Well, we can choose VMAT, and we can choose arcs, 2 arcs, collimator angle 30 degrees, manual NTO. I think that will do, just for the sake of getting a different plan. And then, yeah, this may take 2 or 3 minutes to calculate, but yeah. While we are calculating, are there any other questions? Yeah. You can do that. Yeah. Yes. You can do that. I just show you how to just clean up the structure set. You can always call the process plan plugin and do another plan. Change whatever you want. Have another plan. Change whatever you want. Do however many plans you want.
But you can't. I think maybe you want to do 2 at the same time with different parameters. Not yet.
So we cannot do at the same time. We can do sequentially, but those are like a couple of minutes apart, right? So they go quickly. Yeah.
So they go quickly.
So they are sequential, yes, not at the same time, right? That would be a lot for your treatment planning system.
Maybe Gen 2. Maybe Gen 2, prostate Gen 2.
Yeah. Oh, yes, this one it is. Yes.
Yes. Dermaplan. We have Dermaplan as well. Derma for skin and circle.
Usually it's made for prostate. You can try applying it for gynae, for rectum, so something similar to prostate, like, right? You know, but you have to try it. This is meant for prostate, but you have to try it. But the beam arrangement is similar or the same. So the VMAT start and stop, it's just like full arc, partial arc. I mean, it's pretty much the same. You can try applying it to gynae and rectal as well, and see what you get. I would say try it. Yeah. Yes. Okay. Ah, yeah. Okay. So if Yes. So, well, we already developed it, so it's there. It's tested. It has all these features built in. It took our team almost 1 year to accomplish it. So if you do it yourself, like ESAP is scripting, it will take you a lot of time. You have to be skilled in the programming language. You have to test. You have to test a lot. We have to make a decent UI UX for your team so the team can use it. And if you have to test it a lot. And then if you leave, if you're on vacation and there is a bug or something, it's like it doesn't look good. So if you're an experienced programmer and you can script all that and you have 1 year to script, then it's all good. But it takes a lot of time to script and fine tune it. You can do it. We did it, but we had two dedicated developers, a dedicated medical physicist, several hospitals testing it, beta testing collaborators. It's just a whole team working on it for a year. Yeah. So
And we already have it. Why do you want to make it again? We already have it.
yeah. hmm 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 Yeah, I believe we don't have an MCO function right now. Do you think it would? Yeah. hmm 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 Yes, you can. When you have the final plan, you can do whatever. You can just resume working on it. Yes, you can use anything. Yeah. Yes. 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 Yes.
Dr. Lee, we would like to offer the software and let you try it in your department. So if you have a desire to use the software, we will install it in your lab and let you try it for a period of time. And maybe you can do some comparison plans between the two, right? And we can give you some criteria for comparison if you like, and then we take it away. Right. So
Yes. If I tell you, yeah, yeah. So yeah, yeah. So yeah, the hotspot cooler basically works so that um, when the first iteration is done of the plan, when the first iteration is done, we look at the plan and we look at the hotspots that we gave to the system, like hotspot for PTV high, for example. If that hotspot for PTV high is higher than what you defined, then the algorithm contours the hotspot, makes another objective, goes into the second iteration and tries to cool it down. basically, that's how it functions. Uh, okay. Well, there you have it. Yeah, yeah, yeah. So, but yeah, for us here it works. So this is so we just got a um yeah a VMAT, yeah 105. Just a second. No, just a, just a second. We have to choose the right one. Okay, so maximum is 105.9. Yeah. Mhm. Do you want to look at the DVH? Yeah, just a second. We probably have to check. Yeah, yeah, yeah. All good, all good, all good. Yeah.
One button at a time.
We can normalize now. Also, I mean, yeah, yeah. And this is just one iteration, so it's like, and then you have the this is the VMAT. This is IMRT9 fields. You already have, within this short demo, you already have two plans, right? So it's going fast. It's going fast. It's going fast. Yeah. Yes. Yeah. Yes. Yes. Yeah. 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 So you can use the hotspot correction. It takes a little bit longer than 10 minutes then for like three targets, hotspot, cooler, going into two iterations, treating with VMAT. It takes, so the more complex you have, the longer it takes, but it's still much shorter than manual. Yes.
More code.
Yes. Yes, it is. Yeah, yeah. Serbian. Serbian. Borko. Yeah. Mhm. Yeah. Okay. Yeah, you can choose that. You can choose what that. Yeah. Yeah. You can use whatever algorithm you choose to use. So that is all good. All fine. You can choose that one as well. As long as it's commissioned within your system, you can choose it. Yes. Mhm.
そう、すみません。
네, 말씀하십시오. 네, 예, 거의 다 하신 것 같습니다. 예. 예. 교수님 좋아 보이지 않나요? 네, 네, 예, 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 예. 아, 예, 예, 예.
교수님, MCO는 휴먼 인더 루프가 좀 강한 거고요. 지금 여기서 얘들이 추구하는 거는 자동화잖아요. 어찌됐든. 빠른 시간 내에. 예, 예. 아, 예, 예. 예. 예, 예. 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 무슨 말씀인지 알겠습니다. 예, 예. 예, 예, 예. 예, 예. 예, 예. 예, 예. 예, 예. 예. 네. 예, 예. 알겠습니다. 예, 예. 예. 네, 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 네. 교수님 오늘 너무 감사합니다. Mr. Lee, ready?
Yes.
Yeah, Dr. Lee has another patient to see right now. So let's
Thank you, Dr. Lee. Thank you for the time. We appreciate it.
yeah,
Thank you.
let's keep in touch.
As I said, I would love to be able to put it in and let him try it. That'd be great.
Mhm.
Sure. Perfect. Thank you, doctor. Will you be at Astro in September?
Mhm.
Okay.
네, 교수님
All right.
감사합니다.
감사합니다. 안녕히 계세요.
맞습니다.
terminal.
Thank you. Thank you, Dr. Lee.
Bye.
네, 감사합니다, 교수님. 예, 감사합니다. 고생하셨습니다.
감사합니다. Bye.
예, 예.
Okay. Bye.